Welcome to our Annenberg Research Seminar for this Monday, which is April 5th. Okay, April 5th. Today we have a special presentation by the Annenberg Program on Online Communities, and the person who will introduce our speaker today is Andrea Hollingshead, and is one of the three directors of the Annenberg Program on Online Communities, along with Janet Carlton and Robert McLaughlin. But before she starts, I just wanted to say my own special welcome to Karim, because I first met him when he was a graduate student at the Sloan School at MIT. We were there to give a talk, and we spent a number of pleasant hours both talking ideas and walking a bit around the campus. So it's really great to see him have finished his work and gone on to the...
It happens, yeah. It's true.
It's been really pleasurable to follow his career, and we're delighted that you could be with us here as a guest today. So Andrea, if you'd like to do the formal introduction.
I'd love to. Thank you, Peter. So I'm delighted to welcome and to introduce Dr. Karim Lakhani in our APOC speaker series. Dr. Lakhani is currently an assistant professor in the Technology and Operations Management Unit at Harvard Business School. Karim's area of expertise is in the management of technological innovation and product development in firms and communities. He has extensively studied open innovation in a variety of settings, from open source software communities to new product development. He is co-editor of Perspectives on Free and Open Source Software published by MIT Press, and is co-founder of the MIT-based open source research community and web portal. His research on distributed innovation systems has appeared in prestigious outlets such as Organization Science, Harvard Business Review, and Sloan Management Review, among many others. Dr. Lakhani earned his PhD in management from MIT in 2006. Academia is actually his second career. He also had a successful career in industry. Before studying at MIT with Eric von Hippel, Dr. Lakhani worked for General Electric Medical Systems in Canada, where he was a member of GE's Technical Leadership Program, and as a consultant for the Boston Consulting Group, where he was a founding member of the Strategy Practice Leadership Team. A couple of, fun facts about Karim Lakhani. One of the things I asked him yesterday at dinner was he has had access to some wonderful data sets. He studied in Incentive, and he'll be talking about some of the data sets today. And I asked him, so how did you get access to these wonderful data sets? How did you get access to these companies? And he said, I just called them up. So
this is my GE training.
Yeah. So persistence and, taking a chance can often be very productive. So anyway, I was also telling Karim that, he has visited LA before under nicer conditions, but I told him that, we usually don't get earthquakes and rain. And yesterday he arrived and we had the earthquake, and today it's raining. So anyway, if you come back, I hope that we can guarantee you.
That's right.
So with no further ado, I will introduce, give you a chance to speak. And the title of the talk today is The Determinants of Individual Performance and Collective Value in Private Collective Software Innovation. So let's give a warm Annenberg welcome to Dr. Lakhani.
Thanks, Peter and Andrea. Yeah, and it does, I do recall our meeting at Sloan, and it does happen that you graduate and get a job and publish stuff. And I feel like this is like a Poisson event for me in terms of earthquake as well as rainfall. And we'll talk a bit about that as well. So this is joint work with Ned Gully at the MathWorks. Ned runs these contests as his part-time job. He's very much interested in collaborative communities solving real problems. And so when I came across what they were doing, I again picked up the phone, gave Ned a call, and said, hey, I'm interested in analyzing your data. And he said, sure, you're the first one to have asked me that. So if you do run across interesting phenomenon and they seem like there's a research there, you should never hesitate to pick up the phone, call them, because oftentimes the people running them aren't thinking about it in terms of research, and this actually adds a lot of value to their endeavors as well. And he's an equal contributor to our work here. So let me just give you a framing for my research and where this all fits in. I got interested in open source software as an undergraduate student, as a graduate student, and really sort of focused in on problem solving, how problem solving was happening in these communities. And what I sort of think about here is two things. One, there's a collaborative community perspective, which is the open source side. And I've looked at motivations for participation, sort of the cost for participation, how people join, and the fact that we don't see sort of the traditional manager in many of these settings. I remember when I first got introduced to my faculty at the business school, we have a faculty meeting, and I said, we were supposed to talk about our research, and I said, I study why we don't need managers at the business school. Anyway, it was a fun way for people to remember me. But certainly the setup, you've seen Wikipedia, people have published here on Wikipedia, we've looked at open source as sort of the canonical phenomenon where this is happening. But equally important and also interesting is sort of a competitive market perspective, where instead of people collaborating and jointly solving problems, there's a competition. There's a winner-take-all perspective, and somebody comes up and wins. And here, what I've sort of seen is basically this important role of marginality, where people in the periphery come in and solve problems more effectively than people who might be in the core. Again, we see heterogeneous motivations for participation. In fact, very similar motivations for participation by external folks in communities and in competitions. And we've seen things like the uncertainty in the problem types. The more uncertain the problem is, the better off you are by adding more competitors. And then also the importance of diversity and specialization in the communities in helping to solve this. And then the canonical examples, in Incentive is a marketplace for solving science problems. Top Coder is a marketplace for software problems. And I'll talk a bit about Top Coder near the end of the talk as well. And then a big question is, like, when would you organize a community, which is when would you organize as a market? And interestingly enough, we're also finding that there can be settings where you can have both going on. Examples, again, Top Coder is an example. Threadless, those that know sort of this t-shirt company, is a Darwinian marketplace, but also a burgeoning community as well. And the MathWorks example, we'll see again both things at play. In fact, and after sort of looking at this side for the last 2 or 3 years, what I've come to believe is that, in fact, the substrata of markets are communities. There's a tremendous amount of knowledge sharing and helping behavior going on in markets that we just don't observe. And the typical view of the bazaar, we think of it as a marketplace, but a bazaar is highly social and highly collaborative as well. And I think we've sort of, economists sort of take this one perspective that it's all about the market, and they ignore the community side. And I think we can maybe shed some light here as well. So I'll give you a quick overview about the study, show you the results, and then after Andrew asks me a lot of questions, we'll maybe get to the results. So the setting is basically this, I was warned beforehand, friendly collaborative setting of a competition among software programmers. It's a wiki-like setting where programmers can reuse the code a lot. We have, what's great is an objective measurement of technical performance. I'll talk to you a bit about that. We can trace code completely, so we can go back and examine when the first line of code came in, who wrote it, and what happened to it. Large N in terms of the number of contests we have and the number of participants. And what I'm trying to explain here is this graph, basically. This graph is a graph of performance over time. The vertical axis is performance, so the lower the number, the better off, the higher the performance. Each dot here represents a submission, a coding submission, and the red line traces the best frontier of technical performance over time. And what I'm trying to understand here is we see all these individuals trying to get to the top of the red line, okay, over time. How are their actions to get to the top of the line impacting reuse of their code by community members here? So this is the picture I'm going to try to explain over the analysis. And And what we find basically is that there's both, as in any sort of interesting social science paper, there's alignment and there's tension. So what we see is that as you add new code, it helps with top performance and also with collective value. Novel recombination of borrowed code also helps with performance and collective value. Interestingly enough, as you borrow more code, as you do more cut and pasting of other people's code, it hurts your performance, but in fact, it helps in your code being reused by other individuals. This was unexpected. Complexity here runs, the more complex the code, the better your performance, and at least in this setup, also helps with collective value. And I make the argument here that in fact, the transparent process by which this unfolds can account for the fact that complexity does not hurt in these settings. And then conforming to standards, and I'll give you a more robust explanation of this, again, hurts top performance, but again, helps with collective value. So we have both this alignment and tension, and we'll discuss later, what this means. Yes?
Could you define what you mean by top performance?
Top performance here, it literally is getting to the, as you submit your code, are you the top ranking person at that time of your submission?
And that's determined by?
An algorithm, a machine algorithm that sort of looks at your code, scores it for you, and says, you're top right now. Okay. But before I start, I want to just take a musical interlude and show you this. Some of you might have seen this. This is from YouTube. This is an Israeli producer, Kuriman, and he went through YouTube, scavenging for bits and pieces of music, and put together compositions this way. And it's pretty. He's got a whole album out online of 10 different songs that he has basically taken other people's contributions and then put them together and created this great music. They were all doing it for their learning, for fun, right? Their own purposes. And then he took this. So this is sort of the future already arriving for us in terms of our ability to mash up, take contributions from various sources, and create what I think is not a bad piece of music. I could go on forever, but I'll pass. All right. So anyway, I mean, I think it just sort of shows you the possibilities, and what you will see here, as I'll describe as these people work in the setting, is exactly this sort of a mashup of contributions from many people being put together. There's a lot of implications here for us in terms of online communities and how we sort of think about what enables them and what allows us to sort of do better. So the agenda, I'll go through very quickly the literature and the research question, provide you in terms of context, give you the estimation strategy, results, and then implications. So sort of private collective innovation or open source has sort of become this enigma amongst many communities and many scholars across psychology, management, economics. The sort of this puzzle of sort of individuals exerting private effort and then also simultaneously creating public good is sort of the puzzle that many people have posted. And Von Crow and Von Hippel basically came back and sort of said that, in fact, we have these two very different models for investment in innovation. We have the private model, which much of industry works towards, where you make an investment for your private gain, right? You get intellectual monopolies on this gain, on this innovation from society, right? And that basically creates incentives for you to keep innovating. But that also says you restrict who can get access to it, you charge for it, and so on. Then there is the collective action model, which says that basically in order for us to have a lot of disclosure, we want external subsidies, right? We want to fund scientists, we want to fund innovators to create these innovations, to create new knowledge, and then because they get publicly funded, we make this available as a public good, right? And the focus here is on different ways to provide subsidies and norms for basically disclosure of knowledge. And the puzzle for open source software has always been like, why are these people participating, right? Why are thousands of programmers contributing freely to the provision of a public good? And so, this is classic economist learner into role, are square in the microeconomic tradition, and they say this should not be happening. But what we've seen is that, in fact, this sort of open source mentality has been around for quite some time. Historically, there have been many episodes of sort of collaborative and collective innovation and invention. So starting with the blast furnace technology from Allen all the way to Unix development, we see repeatedly a lot of sharing of knowledge, a lot of private investment for the creation of a public good. So it's not a new thing that we're sort of seeing in open source. The scale is very high, but this sort of sets up many examples as to what's going on. And the explanation for why we see this happening is sort of that the costs for participation are low, and that you can overcome the free rider problem by providing selective benefits to the innovators. So from an individual point of view, for somebody who's an actor in this sort of a community, we think of them as trying to maximize their private benefit, right? In the end, they're going to do it. We sort of take a very rationalist approach. It's all about the individual maximizing some kind of private benefit. And what we see is that this activity appears to be low cost for them. In many surveys and many analyses, it appears to be low cost activity for them. And these selective benefits of sort of having career concerns met, reputation, ego boost, signaling drive the motivation. So the benefit is that they reveal the code, right? But only by doing the work do they get access to these benefits, and nobody else who's a free rider can get these benefits. And what we've seen repeatedly is that extrinsic motivations, in a lot of analysis of open source, extrinsic motivations predict the level of participation, how often you participate. So we do see a lot of intrinsic motivations for participation, but that's consistent across the board in a range of studies. That doesn't differentiate if you will participate more or less. What matters has been actually extrinsic motivations. And actually this perspective for me is more recent. I have a paper on this, but I didn't sort of think about it in this line. I always sort of thought about, it's all about the intrinsic motivations, and we see intrinsic motivations coming through. But to sort of differentiate the level of participation, we find that the extrinsic motivations are the big driver. And that was sort of a new framing of my own research and sort of thinking about this. So we have the individual, but then we also have the collective. We have the massive communities that are working together, that are participating, and we want to sort of say, like, what's the collective point of view here? And here, what we sort of say is that social welfare will increase as others can reuse other people's contributions, right? So no longer do I have to keep problem solving on code that somebody else has already problem solved on, right? I can take that contribution and I can improve upon it myself by adding my own new bits. So that's the sort of the theory. What we've seen, at least in many of these corporate settings, is that reuse of code and reuse of knowledge is actually pretty rare. It rarely happens. And certainly when you look at software reuse and sort of knowledge reuse in software, that is not the case. That's the exception often. And the reason for reuse sort of is driven by needs for speed. You want to get there faster, you want to avoid boring tasks, and you want to economize on resources. And so here what we see is that what matters is that contributions that get reused more often sort of help in the collective value. So that's my distinction here, that on the one hand, we have the individual point of view where you want sort of your own private benefit, but on the other hand, from the collective point of view, you actually want the code and the submissions to be reused. And I'll use this framing throughout to analyze the data that I have as well. And what I do to sort of get at this on this study is to sort of think about when you have an innovation-related task, when you have a problem-solving task, what does the individual do? So from a very basic point of view, the individual has access to some sources of knowledge, right? They can generate new knowledge to solve the problem. They can generate novel recombinations of existing knowledge and solve a problem, or they can do cut and paste, right? They can just go in and borrow somebody else's code and dump it in directly, sort of a Control-C, Control-V argument. So we have various types of knowledge available to us, and the individual is going to make some choices as to what they will do to solve a particular problem. At the same time, this knowledge is put together in a certain structure, right? There's a certain artifact that is being created, and we can actually measure this artifact, and the artifact has performance implications. And so here, the two I use, and the paper sort of goes into gory detail as to why these make sense. There's the complexity of the artifact, how complex, how interdependent the artifact is, right? And this perspective on how conformance it is to sort of standards of how you put an artifact together. So for instance, like chairs, there is a standard as to how we sort of think about chairs, right? There's like 4 legs, there's a seat, there's a back, and this is sort of an acceptable standard on how we put a chair together. So in software as well, there are standards on how you code, which have been sort of defined communally, and we can use those standards to sort of see, does a particular artifact in a collective setting, does it meet or not meet that particular standard along the way? And so my whole perspective is the individual, the person participating in these communities, has access to these sources of knowledge and this design structure, right? And how do those actions in pursuit of getting on top of that red line that you saw, getting top performance, impact the ability to get the top performance, as well as the subsequent collective value. So, right, so I impute no sort of altruistic, well, there may be that as well. For now, I sort of say there's none of that going on. That's a after the fact effect, and it's more of an institutional arrangement than anything else. So the setting is this contest that MATLAB MathWorks, which runs MATLAB programming software, runs on a 6-month basis, right? And it's a combination of Wikipedia, open source, and sort of American Idol. And so imagine if you were on Wikipedia, right, and you made an entry, or you made an edit, and there's a smart, intelligent editor at the back end of Wikipedia saying, Peter, today this is the best entry submission we've received. Congratulations, you're at the top of all of the contributors that have ever made to this entry. So this is sort of the setup that people can take, make contributions to this collective good that is being created, and then as soon as somebody makes a contribution, a smart editor at the back says, congratulations, you're the winner right now. So the setup is as follows. So there's some rules to the contest, and I'll walk you through that. And there's some standings, right? Which sort of, you submit your code, you get ranked, you get rated, and we can see who's on top. Anybody can come in and view an entry, right? So, we can come in and say, oh, Janet's number 1, let's look at this. So Cindy comes in, she looks at what Janet has done. She copies that, adds a bit of her own secret sauce, resubmits it, right? And then now she's on top. Okay? So we can track this level of detail in terms of who's doing what in this kind of a contest. And this goes on for the whole week, basically. And so this is Nathan, right? He's a programmer in New Zealand, and here's what he's sort of saying, right? This is my first MATLAB contest, and it's giving me far too much enjoyment. It's one of the most addictive and compulsive things I've tried. Also, I've experienced physical trembling while making the final preparations to submit code. Is that normal? And then later he says, this contest is the most fun it's possible to have using only a computer. We find individuals here will take time off work to participate. Will skip classes if they're students to participate, because it tends to be a fairly engaging activity. And so the setup is basically there's an NP-complete programming challenge given. Here, this is a sort of a PEG solitaire question. And you have to optimize the algorithm in a way that you minimize sort of the traveling distance of a salesman problem, and also minimize the CPU time, right? So you have to optimize on 2 different dimensions, create a great algorithm that shrinks the distance, but also it runs fast. And the competition here is purely for fun and for glory, right? At the most, you'll get a T-shirt, right, or some tchotchke. In this case, they send out the pegboards to some of the top winners, and that's it. There's no monetary incentives. And so here's all about, I'm trying to get to the top and be on this red line. Being in the red line matters a lot to this community of actors. And the setup is as follows. For a week-long contest, there are 3 phases. There's darkness, there's twilight, and there's daylight. Darkness is where you submit your code to the machine, and it gives you a score. And you see yourself improving your score in that daytime, in that 24-hour period. In twilight, you submit your score, and then you can see everybody else's score as well. So you get a relative performance ranking, you see how well you're doing. And you also get to see what is the technical frontier. And then there's a daylight phase of 5 days where all the code is open at all times. So you can go back and look at anybody else's code, take anybody else's code, reuse it, modify it, and then resubmit it. Right? And so in this contest, we had 111 authors with about 4,000 entries. Right? So a lot of action going on here. And basically, what we see is, again, in this case, the distance here, the score, the lower the score, the better. You have this gradient here of performance and time, right? So that you have many people participating, submitting code, and reusing it. Paul?
How many lines of code are we talking about?
On average, we get, I've got metrics about 200, 400, so it ends up being about 4 or 5 pages of code. But it's in MATLAB, so it tends to be fairly high-level programming. So I've done some analysis, and the factor would be like 10x to 20x to like C programming in terms of what you can get done. Yeah. So this right here, Yikao, and he's here several times so he's here as well. He became the eventual winner. And this is a log scale, so this is actually a pretty massive performance gain that he made right near the end. And I'll show you his final entry so we can make sense of it. So he's a senior lecturer at Cranfield University in the UK, and he participates regularly. So maybe one of your professors is also participating here. And he submitted this sort of 500-line piece. 545-line file to the contest, right near the end, and it went on to win the contest. And so here is actually a visualization of the code itself. What's nice to have somebody working at MATLAB is, in fact, that he can come up with all these great visualizations. So the colors represent different authors, okay? And this is the code that he submitted, basically, okay? And in this entry, there were only 12 new lines at the end that he submitted. And the rest have appeared in other entries from other people. And he only authored about 20%. Right? About 114 lines in the whole submission. And there were 30 other entries that he actually took code from. And here are all the people whose code that this has sort of been borrowed from. Okay? So it really sort of shows this sort of what we saw the video of sort of coming alive and providing performance here. Here I've just given you a snapshot of 7 leaders in the hierarchy of the contest, and what you can see is, in fact, there are very different structures. That some write very little, a lot, and at that red line, the leadership shifted about 181 times, and there were about 40 different leaders in the contest. We just picked a sample of 7. Now, what's interesting is that you can actually submit code with a lot of novelty, a lot of new submissions, right? Or few, right? And it doesn't matter, you still end up at the top in the timeline. And what's interesting is that, in fact, this code came in, right? But over time, it literally got all stripped out, right? So some code persists and exists for a long period of time, and some gets stripped out, depending on how people are looking at it and making sense of it. And we can track that here in this environment. Some other fun facts, basically, that not all the code that's in Yikao's entry debuted at 1. About half did, but the other half did not debut at #1 rank. So people are looking deeper into the code bases and trying to see what the gems might be, and then bringing that up as well.
Do people ever counter code as they go in? They see a really good line of code written by somebody else, and they take that out and put something else in?
Oh,
its place?
typically that gets caught pretty quickly. So that might actually have a low performance score. So the next one comes through, and then people can. It's a very dynamic process that if you try to game it anyway, the norms are such that people will strip it out very quickly. In fact, sometimes what happens is that people will use code obfuscators. So they'll basically take somebody's entry and then run through a parser that will create complete obfuscation of the code. So all the variable names get changed, everything else disappears. And then literally the community gets so mad that people will take the time to re-unobfuscate the code. They'll go back and sort of say, this is what this relates to, and completely comment it out in a way so that nobody can pull these games. So the norms have settled in a way that's saying that you shouldn't be trying to game it in any kind of a way that that gives you sort of advantage by being like cheating almost. Yeah. And then also, just in terms of age, so the average median age of the line of code in this entry, this again, UCal's entry was about 3.28 days. So the code survives for some time. So, basically, somebody like UCal, he's a creator, he's a recycler, right, and a talent scout. He's always looking around to also find interesting new bits of code and bring it in. This is what he said about his process, right? This seems to be my style of participation. A lazy brain does not know how to solve the problem at first, then starts looking around, trying to understand what others do, identify room for improvement, and finding the brain can't stop itself from analyzing the problem even after the contest. So these guys will keep playing the game even after it's over. That they've told MATLAB to just keep the servers up and they'll keep improving it. And, they get totally into it. So what was interesting is here what he did was he was of course playing. You have to keep playing. You can't just come. My economist friend looked at it and goes, "Oh, there must be some strategic gaming going on, right? People are waiting to the last minute and then bam, they come in." We don't see that much. What we see, in fact, is that you have to be a player. You have to be able to learn what's going on in the code base as it's evolving, because otherwise you'll miss out on something that'll be critical. And we've done some analysis where last-minute entrants try to come in and they typically go nowhere. You have to be a participant in the game to be able to be successful. And what happened here was that UCal had identified some people that he knew were good from previous interactions. He saw them submit code and he thought, oh, there's novelty here, there's some interesting things here. So at the last minute he took 4 submissions that were in the queue, right, had not been scored yet, but he thought there's some novel things. Took them and then added his own bit and then submitted that. And this was still, a huge gain that came through. But it was really his talent scouting perspective that really helped him to be the eventual winner. But just to reemphasize, this person here gets a lot of kudos, but anybody who's ever been on the red line is also viewed as being successful here as well. So it's being on the red line is what matters to many of these individuals. So recall again, we're going to look at the sources of knowledge in the code base, and we'll try to see how the artifact is structured. I'm going to basically make 2 claims, and I'm not going to give you all the details behind how I generate the hypotheses. Basically, what I say is that the more new code you have, the more likely you're going to get to the top in the top performance level. The more borrowed code you have, the less likely you're going to be at the top. The more novel recombinations of code you have, the more likely you're going to be at the top, right? And then when you think about code complexity, the more complex your code is, in fact, you're going to actually come to the top. And then the more non-conforming your code is, the less likely you're going to come to the top. And then on the second side, on the collective value side, what we say is that basically novel code will help, right? Borrowed code will hurt. No recombinations will help you. More complexity, less reuse. More non-conformance, less reuse. So I'll sort of show all this as we do the analysis. Let me just show you about the fidelity in the code and tracking code we have. So if you have an entry like here, focal entry I, we can track every single new line of code, all the lines of code that have been borrowed from other individuals, right, and lines of code that they have borrowed from other from themselves as well. And then we can track going forward. These new lines got reused in entry J, in entry K, and entry L. So we can track in a very fine-grained way where the code is being reused. And so for my measures, what we did is we said new code is very obvious, right? You can just count the number of times the number of new lines of code that have come through. The novel combination here is literally lines E, D, 11, 12, and 13 have never been seen before together in the contest. They've been written before, but nobody has put them in this way. So we basically do a pairwise count of lines 11 and 12 is a new combination, and lines 11 and 13 are a new combination. We just do that to get us a null recombination. Borrowed code is literally all the borrowed code that's there. And then the social value of this entry is literally counting how many times the new lines of code in the focal entry got reused by other individuals. And we have different measures of social value that we'll also, collective value, I should say, that we have. Complexity, this is literally borrowed directly from computer science, which is McCabe's complexity measure, which has some issues, but is at least one measure of how complex the code base is. And for conformance, what we did is we took this measure from Unix, which has been ported also over to C and also to MATLAB, which is a measure called lint. So if you're a programmer, you might have heard of lint. Lint basically is an automatic way to test your code to tell you, is this going to be buggy or not? And it's literally based on heuristics about what is good code and how you declare submissions and so on. So lint was developed in '76 by Johnson, one of the coders for C, and then got ported over to MATLAB. And it just is it's a generation of warnings, right? And so it doesn't tell you if it's gonna crash or not. So this code may have problems. So think about this as in terms of a grammar checker in Word, right? When you write a paragraph, you might get all those squiggly lines, and it's up to you to decide if you want to keep them or not. That's your choice. So we sort of exploit this as a way to sort of say, does it conform to established norms within MATLAB for code? Basically, so what we see is that, in terms of descriptive statistics, about 6% of the code submissions, reach the top. And then we have, what's interesting is that only about, in this sort of a game, only about 5, on average, new lines of code get submitted. Okay? And the median is 1, actually. So people are maybe just making a small tweak and submitting it. Novel recombination is relatively high at 247. Borrowed code, again, is pretty high at 246. And complexity measure here, this is actually quite high for the code base. People say that complexity should be at the 8 or 9 level in computer science for it to be reasonable for reuse, and here it's quite high. And then altogether, we have about 26,000 observations across these 11 contests over 6 years. So basically what we did for the first one is a logistic regression, right? Trying to get at who comes to the top or not. And the independent variables are all here. And we have a range of controls in terms of the code size, how novel it was from the leader, time left in the contest, the author-specific and content-specific measures as well. And what we find here, if you want to sort of interpret the betas, is basically that a percentage change in the odds of being a leader given 1 percentage change in X, okay, in the variable of interest for us. So what we find, right, is that the more new code you have, the more likely you're going to become a leader, which makes sense. The more novel recombinations of code you have, the more likely you'll go to the top. The more borrowed code you have, the less likely you're going to come to the top. And complexity, is increasing initially, but then sort of decreases. So that there are some sort of decreasing returns to complexity, but overall, the more complex your code is, the more likely you're going to come to the top. And remember, this is an independent. This is Ned writing a piece of code at the back end to test all the software. And there's a big test suite that runs their code against a range of conditions for that problem. So there's no human judgment here at all, right? That's how good is it? And then non-conformance here again, the more non-conforming your code is, the more likely you're going to come to the top. And this is curious because I thought this would be the opposite. But what the literature says is that basically when you are non-conforming, you can take shortcuts. You can take shortcuts, you can optimize in ways that people may not understand. So the grammar checker is going to alert you, sort of say, there are problems here, but it may actually drive performance. It may actually can take shortcuts and so on. Collective value contribution. So the big thing again to remember is now what we're doing is a count of the new lines of code in a submission, right? And how often they got reused by other individuals, right? But we have the same independent variables. Okay, so we just take the same variables and we see how does that impact reuse of the code base. And here again, what we see, right, is that now we control for entry rank. So the lower the entry, the better off you are. So 1 is at the top. So of course, controlling for entry rank, we can look at many different dimensions, but entry rank matters, right? But here, new code, again, this is sort of tautological. The more new code you have, the more likely your new code is going to get reused. Novel recombination of borrowed code matters, right? So the more novel combinations of borrowed code you have from other people, the more likely your new code gets reused. Interestingly, borrowed code, so the more pure cut and paste code you have, right, the more likely your new code gets reused, right? And I think what's going on is that people are actually, they can't understand your new code without having a reference code base from others, right? This matters a lot here. And then complexity for us here was positive. I think the reason is the transparency, and then non-conformance was negative. Okay? Then we have sort of different values of different measures of collective value. So this is what we had before. We can also look at collective value in the liters. So how often did your code get reused in the red line, right? And the things that disappear are sort of a novel recombination, borrowed code, and complexity. Here, basically, new code helped a lot in your being adopted by the leaders, and nonconformance hurt you. Okay, and this looks at collective value of the first adoption, right? So somebody could come back and reuse your code many, many times, and here we just look at the first time you got reused by somebody else for the first time, and the coefficients are pretty similar to what we had before. And I have like 10, 15 minutes, so I'm going to summarize right now. So what we see basically, right, is that there is alignment, right? We see alignment here between having new code impacting top performance and collective value. Alignment here in terms of the recombination of borrowed code, but attention here, right? Borrowed code hurts you, helps in this adoption by others. Complexity here, at least in this setting, straight up, the more complex, the better off you are. And conformance here is opposite again. There's a tension here where you are incentivized to not make it conforming to standards, but that actually then will hurt you on the other side. Limitations. This might be too literal a definition of new knowledge, right? Where literally you could change, from x equals 1 to x equals 3, and we would sort of say this is the new bit of knowledge coming through. So we have to sort of be careful about how far we extend this. How do we link between this very detailed, fine-grained analysis of code submissions to these larger questions of collaborative innovation, where people are doing some pretty major systems development? The self-selection here of the participants is not a random sample. And the big question, of course, is also how do we apply this to non-coding environments where we don't have sort of the performance score like we get in MATLAB. So I'll stop here and we can chat and have fun.
Questions?
Quick question.
Sure.
Your effects are linear effects, and I'm wondering if you have any linear effects.
I tried a bunch of equivalent and nothing came through.
And then what about the location of time in the market, so that early on, if you're adopting someone else's code, that may have a different impact than if you're accumulating. So the ultimate winner was waiting right to the very end, and he saw the 4 others who were good, grab their code and then walk. He could have done that at the beginning. He could have done that in the beginning. So right now I control for time. I don't actually make a sort of I haven't done a duration analysis at all, if that matters. But right now I just say, allowing for how much time has elapsed, what is going on. But I haven't looked at it from a duration point of view. Yeah, but that may be, we may see start of the contest a very different effect than maybe at the end game. That's a good point.
I have a couple of questions. One is about this phenomenon of the borrowed code. I was wondering if you see any kind of like path dependency going on here, and kind of a social proof where everybody's doing it, so I may as well do it.
Yeah. So the second paper is actually looking at this sort of basically what I'm sort of saying is alternative paths of progression. So what happens is that we get this cascade effect. For a while, everybody's on one bandwagon, and then somebody else comes in and shows performance improvements that weren't expected, and then people switch out. And the question we're asking is, like, when do we see sort of path shifting versus path following? When does somebody break new path versus they just keep going down? Because if we go back to let me go back to this. Here, there's times where this is like there isn't that much performance difference at all. People are eking out very small changes, and then we sort of see this phase come through. So we're basically constructing some measures to sort of help us sort of think about shifting of paths based on the code composition.
Cal made a fairly sizable improvement way there early in the front.
Yeah.
There are a couple of them there.
Yeah.
There are two right there.
Yeah.
So he actually was contributing all the way along.
Yeah, absolutely. And there, in fact, I don't have the figures here, but in fact, you can actually observe, almost a learning curve perspective. You can actually see different pathways, and you sort of see learning. So the novelty emerges here, somewhere up here, and then it gets finally sucked into the top.
The second part of it was it's about the relational aspect of this,
Yeah.
where, and again, you're sort of wondering, like, well, I evaluate this person differently, and I think about myself in terms of my relation to this person and versus a community, and there might be something there.
Yeah.
And that was behind my second question, which is about extrinsic rewards.
Yeah.
The way you were describing extrinsic rewards, I think about an extrinsic reward as cash or a new car.
Yeah.
And I'm wondering if maybe it isn't something more relational, that it's not truly extrinsic as a thing and I value it, but it's my position in this external group.
Yeah.
Maybe that's not even exactly, maybe extrinsic isn't even the right word for
Yeah.
that phenomenon.
Yeah, I think you're right. I mean, I think there's something sort of the psychic pleasure of, like, Yikai borrowing your code. Like, wow, the winner actually had my borrowed code, right? That's great, right? But what's interesting is that right now they're not set up. So and Ned has sort of been toying with saying, could we actually find ways to recognize people's code that ends up in the winners, right? And sort of say, you could take a quick glance at the leaderboard and sort of say, the leader actually, if you click on them, you can see all the different code submissions that are in there, which may cause people to behave in a very different way, or may actually cause uptake of code. Because right now, this is all ex post analysis by me and Ned coming in. But I think there is probably some kind of a relational perspective here, because certainly there are repeat players, so there is a community setting, right? And they do show up and will comment very liberally on each other's code and so on. I sort of for now sort of ignored that sort of perspective and sort of completely flattened it in a way. But I think that's a fruitful way for us to move forward as well.
Question, Steve, Paul?
This was
11 contests, yeah.
contests. Was there much learning over those 11 contests? And was there much, how much turnover was there in the population that participated in each of them?
Yeah.
And you can imagine communities forming within the
Yeah, absolutely, yeah.
Forming teams, essentially, to help each other move forward, and you might pick that up in the comments, the discussions, and
Yeah.
it seems like a rich opportunity.
Yeah, so there's plenty of papers to be done from this data set. So what we do see is that there are some people that have stuck around for all 11, but there's also a lot of transition as well. A lot of people come in and out, and either they fail miserably or they go away. One of the things we are interested in sort of doing is running some experiments here in a way so that we can actually see if we can actually get people to form teams and work independent of the collective, and sort of see if that makes a difference or not. What has happened so far is that as soon as you submit your code, it becomes visible. So we don't see sort of cliques forming. What we in fact see is more critique, where the code shows up and people say, oh, this is crap. This is the gem. I'm going to take that. I'm going to use that, and that becomes very easily available to everybody else on the way. And people will. There's some wonderful slides that Ned has done, in which you can actually. People are playing. Each submission has a name. So they'll play games with the name. So they'll sort of say, buy a ticket 5, right? Or sell a ticket instead. That kind of thing, where they'll sort of signal what they're doing with other people's code entries as well.
How sustainable was the community? I mean, does the graph show that people dropped out? So that's only eCal became the only contributor at the end, or just?
Yeah, so these guys, you know, I think I would say that the turnover between contests tends to be about 50% in terms of who shows up next. So the numbers tend to be around 100 to 150 per contest, and then there's sort of turnover between contests because this is held every 6 months. What's interesting is that MATLAB has, you know, has refused to sort of use this as a way to produce code for themselves. They sort of get really scared of this type, like there's IP issues here galore. You know, there's 30 people contributing who to assign IP to, and so on. So they've shied away from it. But they have evaluated the code submissions, and then they have come back and said that this is far superior to anything that we could have produced internal with this kind of internal perspective. But the sense is that it's sort of people are in for fun, for learning, for enjoyment, and some they'll go away, you know, and new people show up.
So we're looking at the quality of contribution, not level or quantity.
No, I was in this case is literally looking at, you know, I sort of have flattened everything and sort of taken this very narrow because I could to make tracking the data and to just focus in on this red line across all the 11 contents.
I'm curious about how you position this context versus some other communities that are out there. This seems like one where there's a clear individual case and a clear collective benefit,
Yeah.
but where's the collaborative kind of middle ground where there are people in different roles, for instance?
Yeah.
This seems to be a case where I haven't heard you talk a lot about different roles, and this points a little bit just to the notion you were hinting at the knowledge, the type of new knowledge creation being very particular.
Yeah.
Some people being kind of grammar people who kind of clean things up,
Yeah.
being equivalent to somebody coming up with really a different paradigm for how to approach a problem, not being differentiated here.
Absolutely.
Do you feel like some of that is discouraged, and this is the kind of community that might push towards a certain kind of person participating, or are there different roles?
That's a great question. I actually was talking to Anne Marchak just this morning, and her Wikipedia data is showing different roles emerging. Some people are integrators, some people are cleaner uppers, and so on. I haven't looked at the roles, but I think there are different differentiation of roles here as well. Because some people show up with some novelty here, right, and they'll just sort of come up with new code that they think they have a shot. They don't go anywhere, but then somebody can actually spot that new code and then bring it in. And they might be really good at basically integrating new stuff that other people have done and brought it in. So I think there is differentiation. I think what's different from sort of a pure open source point of view, well, I think two things. One, what's similar is that although open source software is viewed as a very collaborative structure, when you dig deeper, what you do see is that it's sort of individuals coding serially, basically. And the difference, though, is that there are a chorus of like 6 or 7 other individuals behind that one person, helping them do the problem-solving activity. But the coding is a singular activity. And then once they submit the code, then somebody else might take that and take it to the next level. But there's never like, you know, we're going to write the code together as an agile programming perspective. We don't see that here as much. We don't see this chorus of people helping each other. Everybody jumps in by writing code because that's the only way you get on the leaderboard.
I actually have any other questions, because I have a couple. One of the things, I'm glad you have this up, is you can see that there's a real gain really early on,
Yes.
too.
Yeah.
And at N, and it's sort of mirrors, and then the rest of it seems somewhat linear. And so I had a couple questions. One is, what do you think it counts for? And I was wondering, one of the things I was thinking about is, do you find that people spend a lot of time at the beginning trying to understand the problem I'm working on, and at the end trying to win the contest and putting a lot of time then?
Yeah.
And do you have a measure of the amount of time spent, like logged into the system, and whether that varies at the beginning?
Yeah, that's a great question. So I think this purely maybe just, you know, like the initial code is terrible, right? And then you can make quick hits. You can take some existing perspective and just make a big dent here. This is actually abnormal. We typically don't see that. We don't see that. We don't see this. We do see drops like this. Like this is pretty significant, and this is sort of, you know, significant. But this is sort of abnormal. And I don't have a good metric of how much time. It's because they don't have to be logged in. They can just submit it and walk away. What we can do is look at what we haven't done is looked at, you know, for individuals, how bursty is their contribution. So if they're making lots of contributions, you know, is it happening, you know, in a certain period of time or not? What we do see, like if you see sort of this sort of a standing wave here, or this sort of standing wave here, it's this guy.
It's 13 hours.
Sorry. It's this guy, the cyclist. It's my computer talking. What the cyclist does, what he does is that he comes in and he literally tries to find some magic numbers in the algorithm. So he'll say x equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And these are all his submissions here. You know, basically he's trying to see if there's a magic number or some magic variable that needs to be. And he'll just swamp the system with this sort of a thing. And then same thing here, basically, right? Where he's coming in and sort of scanning the code in a way to basically. So then you sort of say, well, he's just automated the submission process.
And I did have one other question that I think piggybacks on Peter's first question. Is one of the things that you have is some very interesting dynamic time data.
Yeah.
You know, you have the night, and then you have the twilight,
Yeah.
and you have the daylight.
Yeah.
And I could imagine different kinds of predictions about the importance of novel contributions, recombination, and also reuses.
Yes.
On the basis of how you develop those different sequences. And so, I'm sure you're planning on doing this
absolutely.
at some point.
Yeah.
Anyway, thank you so much.
Thank you very much. This was
Peter has an announcement for next week.
Our speaker next week is Hank Green from RAND. He's going to be talking on social network characteristics, stigma, social support, status disclosure, and health outcomes among PLHA in Uganda. I think he has some very interesting field data he's going to share with us, and I encourage you to come back and join us next Monday. Thanks again.
Thank you.
Thank you.